Okay, so assuming that you've watched the introduction to the normal distribution and you know all of the basic criteria, such as all of these percentages and this, all of this, and it's your basic, you might not be too familiar with it just yet, but you know that these criteria exist. Let's have a look at how we would apply it to some basic questions. So we have the diameter of a rivet produced by a particular machine, x millimeters, is modeled as x is normally distributed with mean 8 and variance. Remember that this is your variance, 0.2 squared. So that means that our standard deviation, sigma, is just 0.2, which is just the square root of this number. Okay, so find the probability that x is greater than 8. Now, unlike the binomial distribution, the normal distribution doesn't have some fancy formula. So what you need to rely on is a good diagram. So let's have a look. Let's draw our diagram. See, mine's not going to be the best, but I'll try and get the point across. That is horrific. Okay, that's slightly better. So knowing that it's symmetrical about the mean, or it should be, this is your central point. This is where your mean should be. And you know that this is also your median and your mode, because your mean is approximately equal to your median. And that's approximately equal to your mode. So we know that 8 is all of those values, and it is the central point. Find the probability that x is greater than 8. Remembering that in the normal curve, the area under this graph is equal to the probability of those outcomes. We're looking at all the values where it is greater than 8. We know 8 is our mean and it is symmetrical about this point. That means that this side of the graph is 50% and this side of the graph is 50%. We are interested in all of this half of the graph where it is greater than 8. And as we know, it is symmetrical about the mean, median, and mode. This is 50%. So the probability that x is greater than 8 is just 0.5. Now B. Find the probability that x is between 7.8 and 8.2. So maybe I will just copy this diagram. And get rid of the shading. Okay. So, probability that is greater than 7.8 and 8.2. Let's add in my 8.2. And let's add in my 7.8. So we're interested in this area over here. Where has this 7.8 and 8.2 come from? Well, we know if I have my mean, 8, and add on 1 standard deviation, that is my 0.2, that gives me 8.2. And if I have my mean and take away another standard deviation, I take away 1 standard deviation, that will give me 7.8. So these numbers are basically the values within 1 standard deviation of the mean. This is my mean minus a standard deviation, and this is my mean plus a standard deviation. One of the facts we've learned is that approximately 68% of the data lies within 1 standard deviation of the mean. So that means the probability that your x is between 7.8 and 8.2 is 68%, 0.68. So that is how we approach normal distribution questions. Okay, let's have a look at another one. IQ for a given population by definition is distributed using X is normally distributed with mean 100 and variance 15 squared. So our mean, mu, is 100 and our standard deviation, sigma, is 15. Find the probability that X is between 70 and 130. So let's start by drawing a diagram. Again, I might just steal the diagram I had before. Get rid of all of that. And I might just copy it so it's clear for my next diagram. Okay, so we know our mean is not 8, it is 100. So we're trying to find the probability that it's between 70 and 130. So if I have my 100 and I take away one standard deviation, that gives me 85, which is not 70. So I'm going to take away another standard deviation, and that gives me 70. So 70 is going to be over here. And we know that is my mean minus 2 standard deviations. So I'm assuming if I have 100 and I add on another 2 standard deviations, I get to my 130, which I do, which is over here. So I know that my 130 came from my mean plus 2 standard deviations. So I'm interested in this area. And the fact we learned in the other video is that approximately 95% of the data lies within 2 standard deviations of the mean. So that must mean that the probability of 70, X being between 70 and 130, that has got to be 0.95. Yes. So now let's look at part B. Okay, so our mean is not 8, it is 100. And we're looking for when X is greater than 115. So if I have my mean 100 and add on 1 standard deviation, I get, wait, my bad. 1 standard deviation, which is 15, I get 115. So my 115 is going to be over here. And that is the result of my mean plus 1 standard deviation. What I'm interested in is this shaded bit here, when it's greater than 115, because that's what the question is asking. Find the probability that X is greater than 115. So this one's a bit more tricky than the other ones. What I'm going to do, first of all, before I find this area, is I'm going to do something else. What am I going to do? Let's have a think. I know if I take 100 and minus a standard deviation, that gives me 85. So let's add in our 85 over here. And that is the result of the mean minus a standard deviation. And we know that this area here is 68%, because approximately 68% of the data lies within 1 standard deviation of the mean. And that is one of the facts that you need to have ready to go. So I know 68% of the data is here. Another fact I know is that the normal distribution curve is symmetrical about the mean. So here's my mean, and that means I know that this area over here on this side is 50%, And on the left side, this area here is also 50%. And another thing I know, I'm probably going to have to rub out some things, is, no, I'll just keep it all there. Because this part here, the blue bit, is 68% of the data. I'm just going to draw another diagram. This is getting too out of hand. Because I know over here 85 and 115, because I know that this part here is 68% of the data and the graph is symmetrical, I know that this part here is 34% of the data. So to find the probability that x is greater than 115, I know two things. I know that this half of the data is 50% because it's the other half of the mean, so this part is 50%. And I know the bit that I don't want here, where it's less than 115, is 34%. So if I have my 50% and I get rid of the 34%, I'm left with the area I'm actually interested in. So 50% minus 34% gives me 0.16. That was probably a lot to take in. So if you need me to go over any of that, leave a comment and I will.